In this problem, we're asked to graph a vertical line that passes through the point -3, 4 and write its equation. Remember that vertical lines are lines that go up and down. So the fact that it passes through -3, 4 means I'm going to start by going over in the graph and picking point -3, 4. The fact that it's a vertical line means that it'll look like this. I need only pick another point on the graph so that the x value is -3. If it's vertical, then that means all the x values of all the points on the graph will have an x value of -3. It doesn't really matter what y value I pick as long as the x coordinate is -3. So I'm just going to pick a point here, and I'm not sure exactly what the coordinates are, but the x value is definitely -3. So this would be the graph of a vertical line that passes through the point -3, 4. The fact that it's a vertical line means that all of the points on the line will have x values of -3. In fact, when I go to write its equation, what that means, all I have to do is say that I have an equation such that all the x values are -3. So the equation of a vertical line always looks like x equals some constant, whatever the x value is. For a horizontal line, it's very similar, except a horizontal line is a line that moves left and right. Students often refer to these as straight lines. But most math teachers think that any line is straight. For example, this would be a straight line, that would be a straight line, as opposed to maybe lining up for the football game and the people in the line sort of make a curve. So when mathematicians use the word straight line, they're actually referring to anything that's not curved. But many students use the word straight line to really mean horizontal. I always correct these students in class when they say it's a straight line, and I say, well, it's a horizontal line. I know what they are saying in their mind is correct, but mathematicians like to make that distinction. So at any rate, I'm going to go over here and graph a horizontal line, one that looks like the horizon. Like if you were on the beach, you'd see the horizon moving left, or not moving, but it would be left and right, and it has to pass through 3, 5. So I'm going to go over here at 3 is x value, y equals 5, and I'm going to put that point there. And the fact that it's horizontal means that it's going to be looking like this. I need only pick a second point. Doesn't matter what x value I pick. It just needs to be that y is 5. So any point along this line here, as long as the y value is 5, would be a horizontal line. So for example, I'll pick this one, and perhaps the x value is -2.5. I don't really care, but the y value is definitely 5 there. So if I had to write its equation, I need to tell people I'm looking for a graph that has the property that x takes on any value, but y values are always 5. So I will write y equals 5. Horizontal lines always look like this. They always look like y equals a constant, and they're very easy to graph in your graphing calculator if you have to, because you just have to type in the number.